Hey everybody. In class today we talked about graphing an equation using slope-intercept form. Tonight we're going to get a little bit more practice with that. So remember, slope-intercept form looks like this. And this is something we've seen before. Y equals mx plus b. Basically, slope-intercept form is when we have y isolated on one side of the equation. Remember that m represents the slope and b represents the y-intercept. So to graph an equation, we only need these two pieces of information. We need the y-intercept, that gives us 1 point, and then we can use the slope to find other points that are going to be on the line. So let's take a look at example A here. We have an equation y equals negative x plus 4. Our first piece of information, our first point that we're given is the y-intercept, b equals 4. So that's where our line is going to cross the y-axis. Now our slope, remember, is the coefficient of the x. And in this case, the number in front of the x is negative 1. Now remember, one way to think about slope is rise over run. So sometimes it's nice to look at our slope as a fraction. So we can think of our slope as negative 1 over 1. If it's not a fraction, we can always write it as over 1. And this gives us our rise for our equation and our run. So we can graph this. I can draw a quick little coordinate plane here with my y-axis and my x-axis. Now I'm just going to have a normal scale here. We'll say our scale is 1 going in both directions, x and y. Now I'm going to plot my y-intercept. Is at positive 4, 0, 4 is that point. And I can use the slope to find a bunch of other points. Now if my rise is negative 1, that means I'm going to go down 1, and my run is positive 1, that means I'm going to go to the right 1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, and we can keep going. Now I can also go in the opposite direction, right? If I'm trying to get to my y-intercept and I go down 1 and to the right 1, I would have to be coming from this point here. So really we can think about reversing both of these directions, about going up 1 and to the left 1. So up 1 to the left 1, and see that still gives us points on our straight line. And now all we have to do is connect our points to make a straight line and put arrows on our ends. And now we have a line that's given by this equation that we started off with. Let's try two sort of different looking equations here. In example B, I have y equals 3x. So this is in slope-intercept form because we notice here that the y is isolated on the left side. So we have equals 3x. So if I'm trying to identify my slope and my y-intercept is b. Now I don't see it says plus anything here. So I can think of this as being 3x plus 0. So really my y-intercept here would be 0. And my slope is 3. So now with that information we can graph our equation. Draw a quick coordinate plane here. Try to stick to my grid. I have x, I have y. My y-intercept is at 0, so that's right there. And my slope is 3. I can think of that as 3 over 1. So I go up 3 and to the right 1. And if I want to get another point, I can reverse both of those directions. Instead of up and to the right, I can go down and to the left, because another way to write positive 3 is negative 3 over negative 1, right? So since I have those 3 points, I draw my line and my arrows. So that's that equation. In example C here now, I don't have y isolated. So I need to do a little bit of work here. I need to solve for y. I can subtract 2x minus 2x. That is going to give me negative 3y, don't forget the negative in front of the 3y, equals 15 minus 2x, and I divide by negative 3. Now when I do that, I get 1y. 15 divided by negative 3 is negative 5. Negative 2 divided by negative 3 is positive 2 over 3x. So now that I have it in slope-intercept form, I could also rewrite this if I wanted as y equals 2 over 3x minus 5. I just got to make sure the signs for each term stay the same. And I can graph this now. Let's draw my coordinate plane. I know I'm going to be starting at -5, so I got to make sure I have space down there. So I'm going to plot my y-intercept at -5 on the y-axis. I'm going to go up 2 and to the right 3, up 2 and to the right 3. I have 3 points. Draw my line and my arrows. All right, let's do one more. Here we have 5x minus 5y equals 20. This is another case where we're going to have to solve for y to find the slope and the y-intercept. So we'll start by subtracting 5x minus 5x. We will have -5y left over, and we have 20 minus 5x. We could also write that as -5y equals -5x plus 20. We can rearrange them as long as the signs for each term stay the same, the 5x negative, the 20 positive. And then we divide by -5. So that'll give me 1y equals -4. 20 divided by -5 is -4. And -5 divided by -5 is 1. So it'll be plus 1x. But remember, we don't really write the 1. So here we have our equation. We have isolated y, and we can identify our slope and our y-intercept. So remember, our y-intercept is always the constant, so that is -4 in this case. There's no variable there. And our slope is the coefficient of x, which in this case is 1 because there's no other number there, just 1. So we can draw our coordinate plane, draw our y-axis and our x-axis, and we can find our points. We know our first point is -4 on the y-axis. And now our slope, since it's 1 over 1, we just use the rise and the run to find other points. I can go up 1 to the right one, up 1 to the right one, up 1 to the right one. And we can do that again, get to our x-intercept. And remember, we can also go in reverse. -1 over -1 is also equal to 1. So I can go down 1 to the left one, down 1 to the left one. And now I have a bunch of points. I can draw my line, do the best I can to keep it straight, and add our arrows. All right, that's our last example. You can go ahead, complete your notes. Don't forget to submit it through Canvas, and I will see you guys in class tomorrow. Have a good night.